Now, things wouldn't be fun without a word problem, and this is going to seem like a very similar word problem from the ones we did in 7.1, except we're going to be able to apply our shortcuts. So we have a 6-meter long ladder leaning against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? How far from the wall is the base of the ladder? Round your answers as needed. Now remember, when we're talking lengths, we go ahead and use decimals because it doesn't make sense to talk about the square root of 3 feet. We don't measure that way. So what is my picture? Here's my building. Here's my ladder. Now, what information am I given? A 6-meter ladder. So the ladder is 6. It's making an angle of 60 with the ground. And again, we assume our buildings are straight up. So that makes that a 30. So I know my hypotenuse, my angle on the ground, or my length on the ground is my short side, and how far up I reach my building is my long side. So going ahead and solving for my short side, remember that 2 times the short side is the hypotenuse. Substitute in what you know. 2 times the short side is 6. Divide by 2. S is 3 feet. So my ladder is 3 feet away from the building. Now, what does that mean for the long side? That means that, remember that the short side times the square root of 3 is the long side. I know the short side, so 3 square roots of 3 is the long side. Go ahead and multiply those together, and we find out that our long side is about 5.2 feet. So we are reaching approximately 5.2 feet up the wall. Now, just to do a fun sports example, a baseball diamond is a square with sides 90 feet long, which also means we have right angles because it's a square. To the nearest foot, what is the length of a throw from home to second base? So we're really talking about this length right there. Well, if you look at that, that really makes a pretty awesome triangle right here. That is a 45, 45, 90, where I'm missing the hypotenuse and no one of the legs. And if we remember our 45, 45, 90 rules, the short leg times the square root of 2 is equal to the hypotenuse. I know the short leg. 90 square root of 2 is that hypotenuse. Quick little calculator work means that that hypotenuse is approximately 127.3 feet. Yes, you could use the Pythagorean theorem with 90 squared plus 90 squared equals h squared, but again, this is going to be faster. Now in part B, it says what is the length of a throw from the shortstop position to first base, here's first base, if the shortstop is midway between second and third. Well, midway would mean that this is 45 feet because the whole thing is 90. Here's my right angle. I know that this is 90. In this case, I don't know anything about the angles. So I'm going to go ahead and use the Pythagorean theorem with h squared is equal to 45 squared plus 90 squared. It's always tricky when in doubt. Use the Pythagorean theorem. If you're not sure you know the angles are 45, 45, 90 or 30, 60, 90, don't take the chance because Pythagoras always works. So this means that h squared is equal to 2025 plus 8100, which means that h squared is equal to 10,125. Square root both sides. H is 100.6 feet. Now we're going to switch over and draw on some old knowledge and some new knowledge. Now the apothem of a polygon is always on the ACT exam. It's a trick question. It's one that tries to mess you up, and it's really very simple. Now, if you remember, the central angle of a polygon is equal to 360 divided by the number of sides. Now remember that central angle is going to be a radius to a vertex, radius to a vertex. That is a central angle. Now what happens is that this apothem, which is this green line, a line segment drawn from the center of the polygon perpendicular to a side, happens to always bisect that central angle that it is in, and it bisects the side. And because these are radii, these are also equal. If you have a hexagon, which is 6 sides, 360 divided by 6 is 60 bisected. I get 30, 60, 90 triangles in these little triangles with that apothem being something I can calculate. Okay, so why do we care so much about this? Because we don't have formulas always for regular polygons. And if we did, it would be hard to remember a bunch of different regular polygon formulas. So what is really slick is there is kind of a cheat. The area of any regular polygon, now remember regular means all the sides are the same, and that formula is 1/2 the apothem times the perimeter. Pretty simple formula. Might need some 30, 60, 90 rules to figure it out, but very simple. So for example, given a regular hexagon with a perimeter of 240 centimeters and an apothem of 8.7 centimeters, what is the area? Initially, I would always say, draw a picture. And I don't have a hexagon. Wait. Here's my hexagon. But look it, they give me perimeter. They give me apothem. The formula is 1/2 AP. So this is plug and chug math. I have everything I need. 1/2 the apothem, which is 8.7, times the perimeter of 240. Put that into your calculator, and you end up with an area of 1,044 centimeters squared. And it is that easy if you're given the apothem and the perimeter. But what if you're not given those things? Given a regular hexagon with a side length 6, what is the area? Well, side length 6, I can calculate my perimeter. That means it's 6 times 6, which is 36. Okay, so I'm good there. So that means that this whole side right here is 6. But I need to think about my central angle. Now, central angle, put a little 1 by that. Central angle is 360 divided by hexagon, 6 sides, which is 60. So this big angle is 60. But the apothem, which is what is right here, bisects it. I'm going to draw this out bigger. Here's the base, which is the whole thing, is 6. And this green apothem dropping down here. It bisects that central angle. So these are each 30, which makes these 60. I need the apothem, which happens to be the long side of a 30, 60, 90, but I also know the short side of this 30, 60, 90. I don't need the hypotenuse. It's not a part of my calculations. If you were given the radius of one of the figures, that is actually the hypotenuse. And there are examples like that on your homework. So here I have the short side. Remember 30, 60, 90. Short side times the square root of 3 is your long side. So my short side is 3. 3 square roots of 3 is my long side, which is my apothem. So I have my apothem, I have my perimeter, and so my next step is to calculate the area. And the area is 1/2 the apothem times the perimeter. So it's 1/2 of 3, radical 3, times 36. Now, still no need for your calculator. These are 3 numbers being multiplied. So I can multiply them in any order. So I'm going to take half of 36, which is 18, times 3 square roots of 3. Multiply your coefficients. I have 54